Hello everyone, welcome back to this online class. Today we are going to look at how to solve linear systems of algebraic equations, and in particular we are going to use successive over relaxation, or what we are calling SOR iteration method. Now we have this question. We are given the system below and we are asked to use SOR iteration to solve the system, starting with the initial guesses that x1 at level 0 is 0, x2 at level 0 is 0, and x3 at level 0 is 0. Perform 3 iterations. So let's see how to go about this problem using successive over relaxation method, or what we are calling SOR method. Now there are two methods that you're going to use. The first one, method 1, is that first of all you express the given system in form of Gauss-Seidel iteration. So obtain the Gauss-Seidel iterative formula for the system, simply the given system. So what happens is that in equation 1, you make x1 the subject in equation 1. So we'll have, of course, you'll divide by 3. Let me make this the subject. So I'll take this to the right, also this to the right. So I'll have x1 is equals to 1 over 3 into x2 minus x3, then minus 1. So x1 will be at level k plus 1. x2 and x3, those are evaluated at level k. Equation 2. Now you make x2 the subject and use the immediate value of x1 that you have found. So it means x1 on the right hand side will be at level k plus 1. So again here x2 is equals to, remember that's equation 2, so that would be divide by 3 again, that's 1 over 3 into x1 plus x3. Then this is plus 7, this is 7 over 3. Even here it was negative 1 over 3 because I was dividing by 3 throughout. Because already I know x1 at level k plus 1, that's what I'll use here, k plus 1. I don't know x3, I'll evaluate that at level k. This is x2 at level k plus 1. In equation 3, make x3 the subject. So what I'm going to get is that x3 is equals to 1 over 3 into negative x1 plus x2 minus 7 over 3. Already we know x1 and x2 at the level k plus 1, the immediate values. So those are the ones we use at level k plus 1, x2 at level k plus 1, and that will give us x3 at level k plus 1. This is Gauss-Seidel. So now when you want to obtain the corresponding SOR scheme for this one, what you do on the right hand side, we are going to introduce what we are calling lambda. This lambda is called the relaxation parameter. We are going to introduce it in this form. Let me write this. It is called the relaxation parameter. It is a value between 0 and 2. So that when lambda, not lambda but omega, when omega is equals to 1, then it will correspond to the Gauss-Seidel method. When omega is less than 1, then it means we'll now be talking of under relaxation. Under relaxation, and when it is greater than 1, we talk of over relaxation. So SOR will pick values of omega which are greater than 1 because from the name, it is successive over relaxation. For you to get over relaxation, the value must be greater than 1. So once you have the Gauss-Seidel scheme in this form, you introduce the relaxation parameter on the right-hand side. So like here, if you look at this equation, the first equation, you are going to multiply this by omega, all of that. Then you also add 1 minus omega times x1 at level k. That's what it means. So the same to equation 2, the all of this on the right hand side you multiply by omega, then you add again 1 minus omega times x2 at level k. And finally, the other equation, you also multiply by omega, then you also add 1 minus omega times x3 at level k. So when you do that, that's what we are now calling SOR, iterative method. So what are we given? We are given that x1 at level 0 is 0, x2 at level 0 is 0, x3 at level 0 is also 0. So let's perform the iterations. You need to pick any value of omega that is greater than 1. So you can say choose omega to be equal to 1.25 as long as it is greater than 1 and less than 2. Because we are talking about over relaxation. So we need to perform 3 iterations. Let's see the first one. First iteration. What do? You need to put k is equals to 0 in this iterative formula so that x1 at level 1 will be equal to omega. Now it is omega times 1 over 3 into x2 at level 0 minus x3 at level 0. Then there is minus 1 over 3 plus 1 minus omega x1 at level 0. Substitute those values. We will have 1.25 times 1 over 3 into 0 minus 0 minus 1 over 3 plus 1 minus 1.25 times 0. What will it give us? This should be equal to negative 0.4167. Second equation, x2 at level 1 is equals to omega times 1 over 3 into x1 at level 1 plus x3 at level 0 plus 7 over 3. Then plus 1 minus omega times x2 at level 0. Again, you need to substitute those values of omega, x1, etc. so that you get your x2 at level 1 to be equal to 1.25. Then here we have 1 over 3 times. Now let me take you back to the equations. Look at the first equation. It was negative, so not negative. Of course, coefficient of x1 is 3, positive and positive. So what we have there is okay. So we go back and substitute. And this will now give us 1 over 3, x1 at level 1, the immediate value we have found, that was negative 0.4167. x3 at level 0, that is 0, plus 7 over 3, plus 1 minus 1.25 times x2 at level 0, that is 0. When you work this out, you need to get 2.7431. Equation 3, x3 at level 1 is omega times 1 over 3 into negative x1 at level 1 plus x2 at level 1 minus 7 over 3 plus 1 minus omega times x3 at level 0. Let us substitute. That will give us 1.25, 1 over 3. The immediate value of x1, that's negative of x1, that now becomes negative of negative 0.4167 plus x2 at level 1, that is 2.7431 minus 7 over 3 plus 1 minus 1.25 times 0. That should give us negative 1.6001. That is the first iteration. Let's see the second iteration. So we write here, second iteration. And so in this case, you need to put k is equals to 1. Put k is equals to 1 in the iterative formula, this one here, so that this is what you're going to get when k is equals to 1. The first equation will be x1 at level 2. It will be equal to omega times 1 over 3 into x2 at level 1 minus x3 at level 1. Then minus 1 over 3 plus 1 minus omega times x1 at level 1. Let's substitute. That will give us 1.25 1 over 3 times x2 at level 1, we got 2.7431. x3 at level 1 is negative 1.6001, so that will be positive, minus 1 over 3 plus 1 minus 1.25. x1 at level 1, we got negative 0.4167. When you press this in your calculator, you get x1 at level 2 to be 1.4972. 4972. Equation 2, x2 at level 2 is omega 1 over 3 times x1 at level 2 plus x3 at level 1 plus 7 over 3 plus 1 minus omega times x2 at level 1. Of course, you can substitute. You know how to substitute now. I don't need to write everything. Your answer should be 2.1880. Third equation, x3 at level 2 is omega 1 over 3 times negative x1 at level 2 plus x2 at level 2 minus 1 over 3 plus 1 minus omega times x3 at level. Now that should be at level 1 because we don't know x3 at level 2. When you substitute those values, you need to get negative 2.2288. Third iteration, here you put k is equals to 2 in the iterative formula, so that the first equation now becomes x1 at level 3 is equals to omega 1 over 3 x2 at level 2 minus x3 at level 2 minus 1 over 3 plus 1 minus omega x1 at level 2. Substitute, you're going to get 1.0494. 94 x2 at level 3 is equals to omega 1 over 3 times x1 at level 3 plus x3 at level 2 plus 7 over 3 plus 1 minus omega x2 at level 2. When you substitute those values, you need to get 1.8782. Finally, the third question, x3 at level 3 is omega 1 over 3 times negative x1 at level 2 at level 3 already because we have it, plus x2 at level 3. We are using the immediate values that we have obtained, minus 7 over 3 plus 1 minus omega x3 at level 2. That should give us negative 2.0141. And so the exact, of course, remember this is the approximate value of x1. This is x2, and this is x3. Are you able to find the exact values, exact solution? Exact solution, you could use Cramer's rule or LU decomposition or matrix inversion method. That will give you x1 is equals to 1, x2 is equals to 2, x3 is equals to negative 2. Look at our values. X1 is 1.04. That is very close to 1. X2 is 1.87, very close to 2. And X3 is negative 2.01, very close to negative 2. So it means if we will have proceeded with more iterations, our approximate solution will have converged to the exact solution. That is the first method. Another method is when you use matrix vector form. Method 2 is using matrix vector form. Matrix vector form. This is how you are going to calculate your x vector at level k plus 1 is given by h times x vector at level k plus c. Of course, k is equals to 0, 1, 2, 3, etc., where h, that matrix, is given by d plus omega L. You get the inverse of this matrix. What you get, you multiply by 1 minus omega times d minus omega times u. That's how to find H. Now the C is given by omega into D plus omega L inverse times B. That's the formula that you're going to use. And remember, you first of all need to write your system in the form that AX is equals to B, where A is the coefficient matrix, X is the non-column vector, and B is the right-hand side. So this is how the system will look like. It will be 3, -1, 1, -1, 3, -1, 1, -1, 3 times x1, x2, x3. The right-hand side is -1, 7, -7. So this is our A, this is our X, this is our B. So remember, A can be partitioned into L plus D plus U. So L is the lower triangular matrix, D is the diagonal matrix, and U is the upper triangular matrix. So in this case, our L is this matrix. Remember, we are dividing. Our diagonal is this. So we need the elements below the main diagonal. That is 0. The rest are zeros, remember. -1, 0, 0. 1, -1, 0. Diagonal matrix is 3, 0, 0, 0, 3, 0, 0, 0, 3. Upper triangular matrix, you now focus on the elements above the leading diagonal. That is 0, -1, 1, 0, 0, -1, 0, 0, 0. Elements above the leading diagonal. So having found L, D, and U, and you know the iterative formula, and remember the value of omega, we are taking 1.25. Our x naught, or simply our x vector at level 0, the initial estimates, those are given as 0, 0, 0. So with this, I hope you can do the iterations, and this is what you're going to get. Just take your time and work it out. The answer, let me give you the answer for this, is that x at level 1 is simply h, which you're going to find, times x at level 0 times x at level 0 plus c. That should be able to give you negative 0.4167, 2.7431, negative 1.6001. Remember that your h should be this. When you do the calculations, your h is negative 0.25 0.4167, negative 0.4167. Here we have negative 0.1042, 0.0764, 0.2431, 0.0608, negative 0.2054, 0.0249. And your C should be equal to, when you use the formula, you need to get negative 0.4167, 2.7431, negative 1.6001. I've given you the formula, so that's your C. Now we have x at level 1. Now x at level 2 is the same as h times x at level 1 plus c. And in this case now you need to get the values to be 1.4972, 2.1880, negative 2.2288, and finally x3. X at level 3, I mean, there will be h times x at level 2 plus c. And so that should give us, these are the values, 0.0494, 1.8782, negative 2.0141. So this is the approximate value of x1, this is x2, this is x3. The same that we found. So use the method that is easier for you. I found the first method as very simple, where you only have to write the given system in terms of the Gauss-Seidel iterative approach, and then introduce the relaxation parameter as indicated in this given iterative system. So that's how to go about this problem using SOR iterative method. Thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving solution of linear systems of algebraic equations by the iterative methods. Bye bye.